here's a fun proof. Let's see if we can do it together. So again, we have some given, and then we're asked to challenge what to prove. So here are the givens, and as I read the givens, I'm going to try to mark them down here, is that AD is perpendicular to DC. So this here is a 90-degree angle in measure, and BC is perpendicular to DC. So this also has measured 90 degrees. So those are those two facts. You can see how I incorporated them in here. What else do I know? I know that angle DAC, do you see that angle right here? This angle right here is told to us to be congruent to angle CBD. That's this angle right here. So those two angles are actually congruent. There's that fact. We're also told that AD is congruent to BC. Look at all these facts. Like this, it's like, I don't know, some holiday time where we just get all sorts of presents. And then finally we're told that BD is congruent to AC. And so I could mark it this way. This length, this entire length, is congruent to this entire length. Okay, great. Our mission is to prove that ACD, this triangle right here, is congruent to BDC, this triangle right here. Okay, well, we have a lot of work to do, and notice it's a little bit tricky because these triangles actually are overlapping a little bit, so we can't get confused by all those overlapping parts. We want to show that we can pair up these two triangles so that each pair of corresponding parts are congruent. Well, a lot of the work has been done for us. Let's check out the sides first. First of all, I see that this side, AD, can be paired up with this side of this triangle, BC, so this part of this triangle corresponds to this side of this triangle, and they're already known to be congruent by the given. Similarly, this diagonal, AC, which is part of this triangle, is known to be congruent to this diagonal, BD, which is part of this triangle. So these two lengths correspond and are congruent. Now what about the third side of each of these triangles? Well, notice that those third sides actually perfectly overlap. They actually are CD, and they're the same. So in fact, CD is congruent to itself, and so I can mark that by saying that that side is congruent to itself. And so now I've actually paired up all three sides of these two triangles and see that those corresponding pairings are, in fact, congruent pieces. Great. What about the angles? Well, we know that angle DAC, that blue angle, is congruent to angle CBD. So these two angles of the triangle are known to be congruent, so that's great. And we also know that ADC and BCD are right angles, and all right angles are congruent because they all have measured 90 degrees. So we have these two angles are congruent. Now what about the third angle? Now where is that third angle for each of them? Well, one third angle, if you look closely, is right here. It's that little sliver piece. And the third angle of this triangle is this little sliver piece. Now, are those two angles the same, and if so, why? Well, let's look at it really carefully. If we look at triangle ACD, what we know is that the sum of the angles of those measures, of those angles, will equal 180 degrees. Now, we know that this angle here is the blue one, and this green one is 90 degrees. So if I add up those two measures, I can find the purple by taking 180 and subtracting off the sum of those two measures. What about the angle here? Well, that angle here, corresponding to this triangle, can be found in the exact same way. I know the sum of these angles is 180 degrees, and I know that this is a measure of a blue angle, and this is a green right angle, and the sum of those two angles will give me some number, and when I take 180 degrees minus that sum, I'll get the measure of this. But since the measure of this angle equals the measure of that angle, and the measure of the green 90 equals the measure of this green 90, I know the sum of these angles equals the sum of these angles, which means 180 degrees minus this sum is equal to 180 degrees minus this sum. Namely, the measure of these two angles, in fact, are equal. And therefore, these two angles are congruent. And we've just shown that every single angle can be paired up on one triangle with a corresponding angle on the other, and then each pair is congruent. That means triangle ACD is congruent to triangle BDC. So it's so important to make sure that we have all corresponding parts corresponding appropriately, and those parts are congruent, and thus we finally prove the theorem. Congratulations.